Hey programmers, welcome back. Right now I want to walk through a Python solution for this tree sum problem. I think we'll hit the ground running. Let's start with the recursive version, which I think is super duper clean. So we'll start with our base case as always. So base case, always about the simplest input we could be given. Here on my input is going to be a binary tree. So what's the simplest binary tree? Well, it's going to be the empty tree, which programmatically means that, hey, if my root is none, what's the total sum of that tree, that empty tree? Well, it's just going to be 0. Cool. What I'm always trying to do is use compatible types. So tree sum in general is going to return a sum, which is a number. So even my base case needs to return a number, right? So the empty number, I guess, is 0. Cool. And now in the general case, how can I compute my actual sum? Well, I can take myself, so my root val, and I can add that with the total sum in my left subtree. So here's where I work in maybe my recursive calls. So I know call the same function. I'm going to pass in root.left. I'm going to have a similar call with root.right. And the way that I combine these is by adding them. That's because I know that this call over here is going to return the sum of all values in my left subtree. So I add that to my value itself, my root val. And I also know that this call over here returns the total sum of my right subtree. And I would also add that. And that would actually be my entire return value, right? So here's how I have confidence in this kind of structure of the recursive call. Let's assume that my root is 3, right? So I check, is root none? It's not, so I have to run my recursive call, right? And so I'll kind of notate things over here a little bit. So my root.val would be the number 3. And then when I make this recursive call of tree sum of root.left would be this 11 node. And so I know by the power of recursion, if I take my recursive leap of faith, this call would give me back the total sum of that entire left subtree. So it would compute 11 plus 4 plus -2. So the sum of that left subtree would just be, it looks like 13, right? And then from there, if I have a call to root.right, this would compute the total sum of that right subtree. 4 plus 1 is just 5. So I'm going to assume I get correct data from both of my recursive calls. And if you sum all these together, right, 3 plus 13 is 16, 16 plus 5 is 21. And that would be my correct top level answer, right? So just by confirming at least one level of my recursion, I can have confidence that it works out, as long as I write a perfect base case as well. So I'll run the test cases for this. We'll see what we get. This is my favorite solution for a problem like this, typically the recursive one. Cool, and there we have it working for this problem. If I look at my test cases, we did test indeed some diverse trees, right? So trees of all different shapes and sizes here, even the initially empty tree. Cool. So while we're here, why don't we also bang out the iterative version? And I'll maybe show you like the breadth first iterative version. So we'll redefine tree sum, taking the root. And by now you should be familiar. I'm going to need my queue. So I'm going to import Python's deck so I get a maximally efficient queue. So I'll say, I don't know, from collections, import my deck, just like that. I'm going to start by guarding because I could always be given an empty tree to begin with, which I'll have to protect against. So if root is none, then that means I have the empty tree up front. So just go ahead and return 0, right? Because an empty tree has a sum of 0. And now I can begin my main algorithm. So I'll initialize my queue by invoking deck. And I'll initialize it with just the root. And I want to loop in general while my queue is not empty. Cool. And how do I begin a single iteration of this algorithm? Well, just remove the front of your queue. So I can say queue.popleft. And that returns to me my element at the front. I'll call it current. I'll take that current element and I need to add its value into a sum. So I need to calculate the running sum. I'll say total sum, need the underscore, total sum equals 0. And I'll increment that total sum variable by the current value. Nice. So here I'm accumulating my sum. And then from there, I just need to check if my children exist. And if they do, I add them to the back of my queue, ensuring that I get queue order, right? So maybe if current has a left, that is not none. Then I'll take that left and add it to my queue. So queue.append current.left. And it's just going to be symmetric for the right-hand side. So something like this. Nice. Now that I'm doing all of this logic, after my while loop, I'll go ahead and return my total sum. Total sum. Nice. So this logic is looking pretty good. Let's give it a run. And now you should know two ways to sum all the values within a binary tree. Nice. So I highly, highly recommend before you go on to the next problem in the sequence, do practice the recursive version as well as the iterative version for this problem.